Okay, so ABN Cast is still going through our meetings on day 3 at Paris Air Show. We've come to one of the chalets again, found a bit of shade because it is probably in the mid-30s, I think, out there. It's very hot. I'm joined by Steve Bleymaier, who is the CTO of a company called Ansys. Welcome, Steve.
CTO of Aerospace and Defense.
CTO of Aerospace and Defense for Ansys. So thanks for joining us, Stephen. Thanks for inviting us to your chalet today. Very briefly, quickly, tell us what Ansys is, what you do.
Sure. Thank you for having me.
No problem.
Ansys, we're the world's largest modeling and simulation company, physics-based engineering simulation. And so to describe it is if you're designing anything in CAD, any product from across the spectrum, from something in aerospace and defense to something in industrial or the energy sector or high tech or healthcare, whatever, you will eventually build a prototype, and then you will test it, and then you will discover what the problems were, and then you'll go back and redesign it and build it and test it.
Yeah.
What our software does is we enable you to do all of the physical environment, all of the physics that product is going to experience in the real world, from mechanical stresses to fluid dynamics to thermal changes to light and optical, all kinds of environmental influences like that. We can simulate all of that virtually, the entire physical spectrum, so you use our software basically to either minimize or eliminate physical prototypes in the most perfect sense. So that when you eventually solve your problems all virtually, and when you eventually build that prototype and test it, it works.
You have fewer actual problems.
Success. So you end up saving time because you can go faster because doing it all digitally and virtually. You're saving all of that money from not having to build all those physical prototypes over and over again. And you're able to improve the reliability and the availability and the maintainability of that product as well, and impact the future cost of operating and sustaining it. And we have solutions that go across the entire life cycle of any type of product or system.
So you're doing this in aerospace and defense, obviously.
Hence our focus is aerospace
being
and
here
defense,
this week, but you do it in other sectors as well.
We do it in all the markets. We have tens of thousands of customers around the world in all markets.
And I guess there's the same principles apply in many other sectors you work in. So the learnings in one are shared across to other areas.
Sure. Aerospace and defense sometimes is a little different just because you have, when it comes to defense, you have the urgency of the need of the capability because it's being built to counter a threat. Those threats are continuously evolving and changing.
The urgent nature of that.
So it increases in urgency. And what we come across today is that these systems that are needed and being developed are becoming more and more complex, but the demand for them is we need them faster and faster and faster. And normally that's two diametrically opposed things. More complex means it should take longer, right? But they need it faster. And so where we come in is we can help speed up that whole process.
It is, and that is happening, is it? I guess there's a sense out there sometimes technology makes things more complicated, more expensive, and longer to enact. That's not the idea. That's not the sales pitch for technology. Technology should actually do the opposite of those things.
In some markets, they've figured it out. If you look at automotive, they have 150 million lines of code in vehicles today, and they do so much digitally, and they're able to bring a car from concept to market in under 2 years now, I think.
Okay, so that's as an example of where it's really,
if you look
really
at the
impacting.
semiconductor industry, they're even faster than that, and they do it all digitally and virtually. And the last thing they do is actually go to manufacture. But the aerospace and defense industry is the exact opposite. They build the prototypes. It takes forever. It takes 10, 15, 20 years in some case to bring a new next generation capability. But it's needed faster. We can't keep doing that. We've got to speed things up.
So you're saying today it's the opposite, but the future of the aerospace and defense industry is that it adopts that kind of approach you've seen in other sectors.
That is the imperative that the aerospace and defense industry has to embrace digital engineering fully and take full advantage of the commercial technology that's available today in order to do all that connecting and collaborative design and development to make it all go faster.
A motto on the wall where we came to reception talked about, I think it's I've forgotten what the exact words, but empowering humans or something. There was a human element to it.
Yes.
Why is that important?
Well, because at the end of the day, it's the humans that are doing the design and the development, and and we want to empower them to further innovation, and ultimately make things better for this world. But when it comes to aerospace and defense, it's about making it, getting it to them faster, more efficiently, saving time and money, and reducing risk.
Yeah. We are at an air show, so there's inevitable some background noise, and we're in the middle of the air show displays at the moment. I'm not sure what that was that was taking off, but it was a big one. So, but that's great. That's what we're here for. It's all part of the fun of being in Paris, isn't it? So tell me about what's innovative in your world at the moment. What Ansys is working on that is going to take us to the future.
We're constantly improving our modeling, simulation, and analysis tools and capabilities that we have, and we've had for many years, and we were either acquiring the best of breed of physics, developing the best of breed, or partnering with the best of breed to bring all of the capability of physics across the entire life cycle and across the spectrum. But we are also investing in high performance computing, giving the ability to bring power to the compute power that's necessary to do simulations and to make them faster. We're putting AI into all of our solutions to make them faster, to make them easier to use. We are using cloud, and we provide an Ansys cloud, or we partner with different cloud providers to provide our solutions on a cloud, so our customers can use it within a cloud, and in some cases, they're able to speed up that process and get access to things they wouldn't necessarily have if they didn't have access to the cloud. And then we enable all forms of digital engineering, and that's that connecting, automating, collaborative, connecting digital thread capability.
Yeah. So with their AI and cloud, things like this on the sort of their modern innovations. In some ways, they're an iteration of what's come before, but it's where we are now. Everyone wants to talk about AI in particular. And some people are quite skeptical about AI. They think it's some sort of, it doesn't really exist. Now, obviously it does, and it's here to stay. What does it really, in practical terms, mean for? Can you do some of the stuff that you're doing without AI, without cloud? Is it absolutely essential that we live in this world of AI and cloud? Therefore, you can do the things you're talking about.
Well, I'm no expert in AI.
Yeah.
Yes, our tools have been around. Our solutions have been around for many years. Some are new. Some are have been developed recently, and they were being used before AI and cloud were.
So AI augments what you've done in the past.
AI and cloud have been around for a while, but to where they've accelerated to where they are today. But we've taken full advantage of them. Because they are the future. They're not only the future, they're the now, and it will only make things better and faster. So
as a company as Ansys, you have your own in-house capabilities working on things.
Yes.
But you also obviously work with a whole bunch of an ecosystem of partners.
We do.
From what? From the big guys to even the startup. A lot of innovation will come from startups, but they find it hard, I guess, to make an impact.
Sure. We have a startup program where we work with startups that don't have the resources to fully invest in technology like ours. We have the ability to make our technology available to them as a startup. And eventually they graduate from the startup program, and they go on to bigger and better things, but they are part of the Ansys family and continue to use Ansys.
Because it's important as a startup, it's very difficult. It feels like, especially in the aerospace industry, it's how do you break into an industry like this, look around and see all these huge chalets and think, well, how on earth does a tiny startup get even close to this? Well, that's the way. You have to work in collaboration, partnership with companies like yourselves, and it's happening. Is it? That's where innovation is being driven. Do you think?
I think innovation happens in many different places. The startups are often talked about as being those innovation, hubs. But innovation can happen in any company of any size if they have the desire, the objective, the goals. They take advantage of the technology that's available today, and they make it a priority.
It's more of a mindset, isn't it?
It is. It is a mindset.
So you are seeing innovation even amongst the really big OEMs of this world.
Sure.
I think you are. I think you hear about it.
Absolutely.
Absolutely. It's happening. So we've been here, nearly 3 days now. Or I guess you've been here.
This is day 3.
It is day 3.
We started on Saturday and Sunday for some.
For some of you, and you'll go on to the end of the week. A lot of people would have come through the Ansys chalet in the last 3 days. What kind of feel do you get? What's the conversations been like? What are people coming to you to talk about?
They've been exciting. Many customers have fully embraced, digital engineering, and they want to go further and they want to go faster, and that's exciting. And others are, freely telling us these are the problems that we need to have solved.
Yeah.
And that's when it gets exciting, when you can say, when people reveal their problems and you're able to help them to work towards solving them. So,
yeah. What areas what areas are they really raising with you guys? I talk a lot about supply chain. I guess that's something where you can help. It's getting parts, getting material into the right places at the right time.
Supply chain is kind of my background when I was in the Air Force in sustainment and logistics and supply chain. So I always have my ear out for what's going on in the supply chain world, and that's been impacted by the geopolitical conflicts that have been going on around the world. So that's taken a hit on supply chain.
Yeah.
But what companies are doing to try to get ahead of that and overcome that are doing things like the additive manufacturing, taking advantage of digital twins to get a better understanding of when things are going to fail in terms of predictive maintenance or condition-based maintenance.
Yeah.
And if they're, when they take advantage of the physics and fuse that with data analytics, you get to an incredible level of predictive capability, up to 98%.
Yeah. Predictive is one of our areas that we like to talk about because we run a conference called Predictive Aircraft Maintenance Conference. So we'll be doing it in November in Dublin and Singapore in September.
You have to send us the details.
I certainly will. Now you mentioned it. We always like when people mention predictive, but it's clearly an interesting area. It's not, again, nothing new. It's a bit like what we were talking about. This stuff, it's been happening for decades.
Yeah. It's
just sometimes it's never been the sort of the forefront.
Right.
I get the sense now maybe it's getting there because predictive does need huge amounts of analytical capability. It does need AI. It does need cloud to really get the most out of it, doesn't it?
Yeah. Well, like I said, if you fuse in the real-time physics.
Yeah.
And that capability that physics brings, physics doesn't lie. I mean, physics brings.
This is science we're talking about.
So that's where you get the certainty that you need to actually get to that predictive capabilities.
What predictive obviously offers for an airline is predictability, which means more effectiveness in operations and efficiency, and that's clearly what everyone's looking for.
It means your entire supply chain is reduced. You don't need to have latency. You don't need to have parts all over the world. Because in case something fails, you can basically do the preventive maintenance at the time and place of your choosing, and really, shorten that entire supply chain tail, and also you'll have incredibly less impact to the mission. You'll be able to fly where you need to fly, when you need to fly there, and have an incredible on-time rate.
And this is good to hear. We feel it is predictive, and the people we get at our conference they don't need convincing. They're predictive people, and it's almost like a mindset for them. They're bought into this idea, and they feel like they're almost like proselytizing out into the industry to say, look, we've got to get onto this. And I think it's sometimes hard to do that in a business where focus is elsewhere. So when they come to our event, they love meeting fellow travelers, But I feel maybe the time has come.
I just think that group of predictive believers, they could really take it to the next level if they will bring in the physics, if they will marry the physics, bring in those digital twins. I think that would take it to the next level.
They certainly talk a lot about the digital twin side of things, and some of these guys.
But some of those digital twins don't really have the physics; they just have the data. So
that's the key. Okay, we'll make sure we get that into the next conference. Final thought on just I guess how you feel about being here. It's always very positive to be with fellow people in the aerospace and defense industry. There's a lot of positivity. You expect that. The sun's out. It's all very happy. Yes. But and maybe you've been to many of these, so you'll know how it works. As you go home at the end of this week, do you go home in a more positive frame of mind, and some realism behind that we're moving into a positive period? There's challenges, we know that, but there always are, aren't there?
Yes, I mean everyone here is usually has the same purpose and many of the same problems and challenges. So it's a community that understands each other, and you understand what the goals and objectives are. So it is a fun a fun atmosphere that's business focused, but it seems like we're going after the same objectives, and that's to really improve the defense of all the nations represented here. And that's always exciting. And then for me personally, I went to the Air Force Academy. We had French exchange cadets, and so coming here is really neat in that aspect.
Yeah. Harks back to your days in the forces.
Yeah.
Cool. Look, Steve, our time's up, but thanks very much for inviting us onto the chalet and having a quick chat with us today. And,
all right.
All the best.
Oh, and I also came here for my honeymoon, so coming back to Paris.
Where else to go?
I can't forget that.
Where else to go for a honeymoon?
That's right.
Well, great. Enjoy the honeymoon,
right?
If that's what you're going to do at the weekend, I guess. So,
all right.
thanks very much.
Thank you.
Cheers, Steve.
Yeah.